Okay, we're going to be rolling right into the second presentation. As mentioned, this is a team presentation by the both site and transportation teams, as they had a lot of overlapping missions. So go ahead, gentlemen. Make sure you always come to talk to the microphone when it's your turn to speak.
All right, so like Posse said, we are the two site and operation teams. First, we have Team A, includes myself, Trent, Mitchell, Mark, and Josh.
Team B includes our project manager, Chris, Everett, myself, Russ, and Adam. So just to recap the sites, we were split up the two teams. My team, Team B, had Cadillac, an existing site, which can be seen on the map on the northern part. And we had Rosebush, the Greenfield site. But Team A had the existing Baldwin site and the Greenfield Clare site. So the scope of work for both teams, we're trucking and circulation analysis to and from the existing, or to and from the planned mine itself and to the existing and greenfield sites, pavement design for all four sites, rail design or rail operational analysis if there's already rail there, drainage design, quantity estimates, and cost estimates. So some design-based assumptions is that all sites will be serviced 5 days a week. 5-day operation requires 1 day of storage, which is 13 rail cars. So phase one of the project will be 325,000 tons of potash per year, with the projected expansion for second year, 650,000 tons of potash. And for our rail design, we use CSX standards. And for our road design, we use MDOT and AASHTO standards. So a typical rail car is 60 feet long, but we use 65 feet for design. Just so we have some leeway in our, I guess, our estimates. And they carry 100 tons of potash and they're covered hoppers. The design vehicle was called a Michigan Double, which can be seen as 73.3 feet long, which the legal max truck length in Michigan is 75 feet. So we're just under. The minimum turning radius for our pavement design can be seen as 45 feet from a central point to the outside of the curve. So we use that for all of our pavement design and all of our sites.
Here we have some material specs. On the pavement side of things, we started off with a foot of class 2 granular subbase. On top of that will be 12 inches of 22A base. And then we have 3 courses of asphalt. First 2 will be 2 separate courses, each 2.5 inches of 13A with 0.1 gallon per square yard of bonding agent between them. And then to top it off will be 1.5 inches of 36A. For the rail, we got 4 inches of sub ballast, 6 inches of ballast underneath each tie. And then the ties will be 6 inches by 8 inches by 8.5 feet. Our rail sections will be 39 feet long each. And these are 115 RE rail, which is designed, it's a heavy rail designed specifically for mining. Quick overview why we chose asphalt over aggregate or concrete. A couple pros: it's cost effective, it's pretty quick to install, easy repairs, and then importantly is it's flexible under loads, which there will be quite a few loads on these sites. A couple cons: it creates greenhouse gases, and its longevity compared to concrete is a little bit lacking, but we feel that the pros outweigh the cons, and that's why we chose asphalt. This shows a typical pavement cross section. It just emphasizes what I said in the material specs. You've got your foot of granular subbase, followed by your foot of aggregate base, and then 6.5 inches total of asphalt with the 3 separate courses. Oh, sorry, I wanted to go back. The ditching for the most part is going to be what you see here, but each site is going to vary slightly. And the same goes for the sloping and crowning of the asphalt. Each site will vary slightly, but this is typical of what you'll see. Same thing goes for the railroad cross sections. You can see the 4 inches of compacted sub ballast, 6 inches of ballast on top, and then you'll have your rail. And just like I said before, the ditching is going to slightly vary, but that's it for the most part.
And then for our rail operations, we chose to use trackable wheels. This would eliminate needing the need for a mainline locomotive to be on site for our switching operations. And it also went with our wanting to make sure we did all the switching off the main line. By using a trackable wheel, we would save quite a bit in operations costs versus maintaining a railroad locomotive on site and the crew that goes along with it. And then next up, we're going into our quantity analysis. This is one of our first steps to determine what the size of our sites would need to be. So we started off, all our sites, initial designs are based off of the phase one, 325,000 tons of potash per year. And then we broke it down using 50 weeks per year and a 5-day operations week. This gave us a total of 1,300 tons that would be transported per day. This would be based on like one site. And then from that, it would take 24 Michigan double loads per day from mine to transload. And that would be loaded into 13 rail cars, which with a 100-ton capacity. Going in. And then going in here, we calculated travel times between the mine and each transload site. We base this off of using Michigan doubles and a max speed of 56 miles per hour. And then we did winter timing, and we added a 15% onto our summertime to calculate that. And that was because most of these routes are based on either US or M routes, meaning that they are the first to get plowed and get the most attention in winter. From that, we were able to calculate our fleet sizes for each of the sites, with Cadillac and Rosebush needing larger fleets due to them being farther away from the mine site. Next, we're going to go into our site routes. First up here is Cadillac. Yeah, the mine here is in the bottom and the site is at the top. We broke down into Class A, non-Class A roads. The difference being that a Class A is a all season. Non-Class A would have to adhere to spring weight restrictions, which meaning that we would need to either upgrade the road, or during weight restrictions, they would have to increase fleet size to accommodate a lower capacity per truck. And then at the bottom here, we went over the lowest bridge rating for each of the routes. This is the 5 was for all of them. That's a fair bridge, meaning that there is no present concern, but with increased loads that it could deteriorate at a higher rate. One issue with the Cadillac route is here, this is the corner of Boone Road and Mitchell Street, north of Cadillac. This is, talking with the county engineer, this is the busiest intersection in the county. And there is a light, which would be helpful, but any summer traffic backups would mean this could back up traffic and it would limit expansion, because they would have a hard time keeping traffic flowing. Next up is our Rosebush site route with the mine here, and in the lower corner, the site. This was the same in terms of Class A. It had a larger amount of Class A, and then it also had the bridge rating of 5.
This is our Clare route. As you can see, it's distance of 35.8 miles and a travel time of 42 minutes. Like the other 3, it's mostly Class A roads, which is good, except for a small piece right by the mine. And then we found no potential hazards or concerns with this route. Baldwin is a little bit shorter, a distance of 32.3 miles and a travel time of 38 minutes. This is the closest route, and it's a pretty straight shot once you hit US 10. However, we did find one potential concern at the intersection of Washington Street and Michigan Avenue. The trucks that will be traveling on Washington Street will come to Michigan Avenue and have stop signs on either side, while the traffic on Michigan Avenue will have blinking yellow lights, meaning that they will not be stopping. We were not tasked with finding a solution to this problem, but we wanted to make sure that it was known and everybody was aware of it.
So getting into the first Cadillac existing site, these are some pictures taken from our field visit downstate at the beginning of the semester. You can see the existing loading structure that goes over the rail here. in the existing trucking loop that is gravel right now, and some of the existing conditions of the track that is there. So for our Cadillac site plan, we plan to pave this existing gravel loop right here. The trucks will come in, there's some truck parking right here. They come through, unload the potash, and the potash gets loaded onto the train right here. There'll be 3 rail road crossings. This is the only site of the 4 that will have any rail crossings. Some key aspects: paving the existing loop, design storage for the trucks, design drainage for the whole system, and rail operation analysis. Some limiting factors of this site are budget and time, the pre-existing rail conditions, and the partial limitations. So the specs for the rail grade crossings are just CSX standards. We plan to go with concrete with rubber panels. You can see that concrete is paved up to the road surface as shown in the spec below. And for the existing rail, since we plan on using up this rail line right here, we'll shut off, and any other rail traffic that comes through can bypass on this bypass lane coming through. So when we are loading up our rail cars, we'll be loading up on the main line here and have storage down here, but any other rail cars that come through can easily bypass. And you can see that they all connect up at the south end here.
So what Russ just said, looking at the rail operations at Cadillac, we had to make sure that the site could actually function properly with the given 13 rail cars that we're designing for. So from that, we have split the existing track into 3 different sections, as seen here. In section 1 in yellow, that can hold 32 rail cars. In section 2 in the red can hold 10 rail cars. In section 3 can hold 6 rail cars in green. And then here are recommended operations for the site. First, you'd like to store the track mobile on section 3, so that's out of the way of the locomotive, so it can drop off the rail cars at the. So you want to store the track mobile on section 3, so it's out of the way of the locomotive when it drops off the empty rail cars at the north end of section 1, just south of the turnout there. And moving on, the next step, track mule is gonna move 2 cars at a time to be loaded. It's gonna come from this siding here. Gonna switch off and come back and pull it to be loaded. And from there, those loaded cars are gonna be pushed back to that section 3, as seen by the arrows. Then for the next steps, you're gonna repeat until section 3 is full, as seen in 6 loaded rail cars. And after that, the track mule is gonna have to come off the track using the grade crossing, then loop around using the bypass and come back over and switch on back to section 3. And after that, it's gotta push the remaining the loaded cars to the north end of section 2. And for remaining empties, you want to repeat steps 3 and 4 as seen here. And after that, the track mule's got to come off the track again and then move on to the bypass siding and loop around to the north end of section 2, where it will push those rail cars to the south end of section 1. And after that, you take those loaded rail cars from section 3 and place them back onto the section 2 here. And after that, the locomotive can come in and take the loaded cars on their way.
So for our drainage design, we were kind of posed with a couple engineering challenges. So since this actual structure is within the rails, essentially we really have two sites, that being this section between the rails and the loop on the west side of the site. For the west side of the site, we have a 2% crowned road that cross slopes into two 6x3 triangle open ditching. The site has a natural pitch westward, so we would utilize an 18-inch circular concrete culvert, which was estimated to handle the 100-year design storm, which would drain into this open ditch and then out into a detention pond, which was estimated by our environmental team to handle the 100-year storm as requested by the client. In total, the surface area taken up by the detention pond is a 90 by 30 by 4 foot deep pond. And then for our section in between the rails, we were really constrained by the existing building. And unfortunately, this section was almost the low point of the site. So right now there is a gravel road and there is no pre-existing drainage. So for that reason, we assumed that a leaching basin would be adequate, considering that the only runoff really associated with this side of the site is from the impervious surface of the asphalt. So for that reason, we utilized two 48-inch leaching basins that are approximately 11 feet deep that were analyzed using the first flush method in order to handle 100-year storm. So yeah, important thing to note is all these cross slopes on this section of the site slope towards the drainage section. And as we transition across the site, they begin to transition into a crowned road, which drain to both sides of the road and then back into a pitching towards the drainage.
Now moving on to our other existing site, the Baldwin site. Here we can see some of the photos taken from our site visit showing the pre-existing track and some of the land around, as well as a map showing again where Baldwin is in Michigan. So as for Baldwin site plan, so the first thing you can see here is the trucking loop that we designed. So trucks coming in and would enter the site here. All this would be paved, and as you can see, it is a 24-foot wide path, so allowing enough space for both trucks. And then we can see here that the loop where the trucks will be turning around so they could access the proposed structure is a 60-foot turn radius, which is allow enough space to make the turn completely. And since there is a trucks entering exit here, we also have a stop sign, so that which would need to be implemented. And then, yeah, the proposed structure where it will lie here. This is the drainage design that will work with this site plan. So as can be seen, we have open ditching all around the entire loop to help take water, to hold the water and take it away from everything. And then also, as environmental, I pointed out, the site is relatively flat with a slight downward slope from east to west, as indicated by the elevation marks. And then the retention basin that was recommended by the environmental was a 120-foot by 40-foot basin located here. We also have 15-foot circular concrete culverts at the entrance of the driveway, and then right before the loop. Unlike all the other sites, Baldwin's rail operation was a bit different. We were actually provided by Genesee Wyoming Railroad a proposed design that they had created, which we've seen here. adding three new storage lines to an existing line there. So we had decided to move forward with design, and a little bit of the analysis we did, we found that this design to the east of it is an existing rail storage, which we used in combination together. So due to design being already proposed and us accepting it, we didn't do a in-depth rail operation for this site.
So the Rosebush existing conditions, these are just some pictures from our site visit again. The Rosebush parcel is right across from Ron Brown's Brown Milling Incorporated. So he already loads rail cars with his greens across from where we plan and designed our Rosebush designs. So like I said, Brown Milling is directly across from where our design takes place. So you can see our trucking loop that we designed. We have parking right here. The trucks will come in, unload the potash. They'll be then loaded into the rail, turn on the trucking loop and head out of there. Some key aspects: there's storage for the trucks, the trucking loop, design drainage system, and rail design and operational analysis.
Although there might be existing rail at the Rosebush site that's already operated by Brown Milling Incorporated, we have to design new rail for potash operations because we don't want cross contamination between the mill rail cars and the potash rail cars. So with that, we had to build this new rail based off of CSX standards. And with that, we have two number 10 turnouts and connecting the main track to the storage siding, which is indicated as the industry lead track there in green. And then two number 8 turnouts connecting the storage and loading sidings, which the loading siding is the private industry track in purple, and red box, that's our proposed loading structure. On the loading siding, we have 400 feet of available storage. And on the storage siding, we have 1,170 feet of storage on that siding, which equates to total storage capacity of 24 cars. And it's important to note that the spacing from the main track to the storage siding is 15 feet, and the spacing from the loading siding to the existing main track is 45 feet due to property constraints. And another thing to note is that this design is pretty constrained due to the property size. A lot of the curve radiuses and standards had to be somewhat deviated from just to make the site the function. And so with that, here are proposed rail operations for Rosebush. First, we want to store the tracking wheel on just south of the loading building, and it's going to move down from there and switch off onto the loading siding or storage siding, where it's going to grab the rail car and push it back up that loading siding to be loaded. And we made sure that there was enough clear space between the turnouts and the clearance point that switching operations were possible. And next step, like I said, push the car to be loaded, and you're going to repeat that until that purple siding, the private industry track loading siding, is full. Then We're gonna have to pull the remaining empties forward and then push the loaded cars back to the north end of the storage siding. And repeat that process until all cars are loaded, then we can go back and push all the rail cars together for locomotive to come and pick it up. And for future expansion, we simply kept the previous design, but added another number 8 turnout for this expansion track. This is going to be a crossover, and we propose that to be 1,700 feet, which has a storage capacity of 26 cars. This can be extended further or reduced in length depending on how operations go and the client's desire. And this expansion plan has a total storage capacity of 50 rail cars, which is plenty, and there's obviously room for more in the future.
So our drainage plan for Rosebush also posed some more kind of engineering problems. As you'll see on this picture and the next, there really isn't a large open detention basin like the other sites. For this reason, we had our environmental team estimate the 100-year storm capacity, which was approximately 570 cubic yards of runoff. And we chose to utilize a 6x6 triangle open ditch that runs approximately 855 feet, which accounts for this runoff. Also unique to this site is the fact that there is a pre-existing structure that ties into the Rosebush system, which offered some, I guess, leeway without a detention basin. So as the trucks pull in, you see we have a crowned road that drains to the west towards the open ditch and down east towards a concrete curb, which drains into a gutter system. The culverts that run under the road are 15-inch circular concrete culverts as compared to the 18-inch at Cadillac. And another important thing to note is that the longest culvert we have running here is approximately 150 feet, which did add significant cost to the drainage plan. Another significant cost was also the concrete curb and ditch which was incorporated into our overall drainage cost in the further slides. The concrete catch basin is a 48-inch, and it should also be noted that there is a natural pitch southward towards this pre-existing roadside ditch. So that's what enabled us to use this open ditching system that ties into the existing structure. So this is the second half of the site. Again, it's important to note that we have 2 more road crossings here with 15-inch circular concrete culverts and 2 more 48-inch catch basins. We did run into a problem here because since there is ditching in between the 2 rail lines, we did have to have some sort of railway crossing, which we estimated through CSX standards to be a 25-inch by 16-inch elliptical corrugated culvert. And as you can see here, here's our ditching, or excuse me, the concrete curb, which drains backward into this structure. And it should also be noted that here we have on the west side of the loop, we have a cross slope into the open ditch. And as we round the curve, it drains into this structure and then back against this curb. And as we make our way through the high point of the site, which is the proposed loading building, it drains away from the loading building in both directions.
This is our final proposed site. This is the Clare site. It's the largest site. 3 of these images are from our site visit. This one here shows the existing main line owned by Great Lakes Central, which is about 5 feet above the existing ground surrounding it. And here's just a map to touch back on where Clare is located. Here's our primary design. It's designed to be serviced after a maximum of 1 day. And This was in response to the wetland delineation when we found there to be no wetlands. We were able to use the entire property. This allowed us to use 2,980 feet of total track, which is the entire rail front property. And this is space for 12 cars east of structure and 12 cars west of the structure. The yellow line here is the MDOT right of way, so everything will be just outside of the MDOT right of way. This is the primary pavement design. All the truck turning radiuses are designed for 60 feet. And the green boxes are designed as to be in scale for the size of the trucks. So you can see there'll be space for trucks to wait to unload the potash. This is the pavement design with storage that the structure team designed. This is the same design, except the road diverts off the two-way a little sooner, which allows for 92 feet of open median south of the structure. This here is the Clare drainage design designed by the environmental team. The blue bold lines, dark blue, is open ditching, and the light blue are culverts. Everything on the site flows from the west to the east. So from here, the road is crowned in the center to go towards open ditching on each side, where it's going to flow generally to the east and using culverts to get ditching all the way to the retention basin here, which is designed at 120 feet by 40 feet by 8.5 feet. All culverts are 24 inches besides this one here. This open ditching runs between the proposed siding and the main line. And this culvert is 18 inches. There's also another 18-inch culvert up here for the bit of ditching that's still going to be running to the east. We'll utilize this culvert here to drain to open ground. Clare site rail operations are the simplest of all the sites due to the amount of rail front property we were able to work with. The locomotive would bring 12 rail cars in from either side and drop them off on the west side of the structure. A trackmobile is then able to grab 3 cars at a time and begin pulling them to the east and then storing them on the east side of the structure. And this will be done 3 more times till all 12 cars are on the east side of the structure, where they will be picked up by the locomotive and carried out. And then 12 more cars could be brought back in and stored back on the west side, where we can repeat the process.
So here's, we have the typicals for the Clare site for the rail. One thing to note here, we had designed a path for about 15 feet for the trackmobile to move around the cars and around the structure. That is, so they wouldn't, the trackmobile wouldn't have anywhere else to move other than by staying off the main line. So we do, one thing about Clare is that it deviates, the elevation of the side track deviates from the main line quite a bit. I'll know the later slide, but the existing track from one side to the other side of the property is about 20 feet, and to be able to store the cars on a level, a more level surface, it does deviate quite a bit. Like Mitchell said, we do have a open ditch for drainage. We see here, we have 6 inches of ballast under tie, 4 inches of granular material. So, and here we have an expansion option. This would be about, so 40 feet from our proposed design, that would be 30 feet from the existing. So we'll have 24 storage for 24 rail cars due to elevation
being able to store them on level ground. By having this 30 feet off the main line, we are able to have it inside of the right of way to be able to use relay rail. And these will utilize number 8 turnouts on each end. Like I mentioned earlier, we have from what we were able to get with Google Earth and USGS topo, we had gotten 20 feet of elevation difference between each of the turnouts for our proposed design. And that's about 2,975 feet. The turnouts would be constructed right at the edge of each of the property. So the property will need to be, this property lines will need to be surveyed to be able to know exactly how far that is. We were able to have 24 cars of storage on this 0.25% of grade. The 12 loaded and 12 unloaded. So that would leave the rest of our rail to be constructed at a 1.47% grade, and that will, it's not ideal. I guess that will be something to be maybe of some concern. And then to make the most gradual grade, we had to use the 100-foot minimum vertical curves, and right here will be the storage building, and that was designed at a 0% grade.
And then this year is our preliminary cost estimation for each site. We broke it down between railroad, roadway, and drainage. And these costs are just for the transportation side. Our sources for our railroad was industry standards over the last year. And then our roadway and drainage were taken from the 2021 January through June MDOT weighted average. And where possible, we took a region specific for each of the sites. And then looking in further, one major cost savings for some of the sites is relay rail. Relay rail is rail that can be used within the MDOT right of way, is rail that MDOT has on hand that would provide major cost savings to the sites that it is most utilized. And that currently, without expansion, is Rosebush. It would create the largest cost savings. And then Clare is the other site where it would create cost savings, and that could help with the expansion alternative. From the sites, we see that Cadillac is the cheapest. That is because it has the most existing infrastructure of these sites. And then next up is Rosebush, and this is because it is the smallest of the non-built up sites. And it has the largest drainage cost because of the complexity of the site and it being smaller, making it harder to get away with just open ditching. And then the Clare and Baldwin sites are pretty similar, with each one the cost being close due to the similarities of their designs. And then balancing this with our yearly estimated trucking costs. So this is mainly based off of the distance to each site, with Baldwin being the shortest and Rosebush being the longest, which leaves a $150,000 difference in yearly operating costs, which would be balanced with the initial capital costs for each site. This leads into our recommendations.
So we came up with a few recommendations for which site we believe that would be the best site to use, or best sites. So our number one recommendation is the Baldwin site. This site has access to the Genesee Wyoming Railroad. It has, as the other three have, are Great Lakes Central. It is a fairly big site. I believe it is 8 acres. So there is room for expansion. And there is an existing rail yard, very close to it to be able to use, for all storage. But one of our main recommendation, it's the shortest trucking route, so that compiles year after year of being the cheapest. One thing to note is the intersection that Trent had pointed out in the trucking. So our second recommendation is Clare. This one is accessed by Great Lakes Central. It is the largest site at 19 acres, and so there is room for expansion. And like the first one, this is the second shortest truck route, which makes yearly operational costs cheaper. Easiest access to road. It is mostly on highways and US routes. So mostly Class A, like Trent had said, other than the 1.5 miles right by the mine. And then the thing to note for this Clare site is the potential grade issues, being potentially 20 feet difference between each of the turnouts. And so for our next steps that we would recommend is to inspect the rail conditions, existing rail conditions at the Cadillac site. Have professional surveys done for each of the sites, especially Clare, I believe. It would be good to know exactly what the elevation difference is, and hopefully it is less than what we believe it is. So soil testing for each of the sites. And then we would want the vertical design professionally done with the professional survey information. And like with all construction, MISTIG will need to be done. So and then the review of all the operations with the railroads for each of the sites, whichever one they're chosen. Exploration of other expansion alternatives for each of the sites, and for any of the non-Class A roads that are used by the trucks, will I guess there'll have to be analysis done to see what will be needed to upgrade the roads. I guess, does anyone have any questions?
Questions? Questions from the online folks?
We got one.
Really dumb one. So I've never had a transportation class. So what is a number 10 and a number 8 turnout?
Those are standard stuff for CSX rail. Number 10 is ideal for like locomotive operations for switching on and off tracks. That's number 8, less ideal for smaller cars. So
What's the difference?
And one of the main
Yeah.
things is the angle that they go off of the main track. A number 10 is a more gradual angle, able to be used at higher speeds. And number 8 is more for the smaller, slower rails.
Other questions? Questions from the online audience?
Did you guys consider alternative solutions to move rail cars, kind of like winch and cable systems as opposed to just track mobiles and shuttle wagons?
We didn't look into that, but that'd be a good thing to look into as well. I'd imagine it would work for sure for the Clare site since it's a pretty simple site. But it'd have to be looked into for the other sites as well.
I'm gonna ask a couple of questions. One thing, you mentioned about how many trucks you need, but how many truck loads do you have? How many is it per day?
24, I didn't highlight that.
Oh, that was there, we kind of
Yes.
must have missed that. So you talked about the Class A roads. Is that the same thing as a truck route, or is there some different definition still between what is identified as a truck route and what is not?
There's still, so like a commercial route is for, to allow a higher load. The Class A is simply seasonal restrictions.
So did you look at how big portion of your routes were classified as truck routes?
The rest were all, except for a couple of different areas, but everything we used, the M routes and the US routes were all classified as truck routes.
Truck routes.
Yeah.
So generally, when you say Class A, you mean it's an all-season road?
Correct.
Hey, this is Jeff Cummer with Michigan Potash. Question on the Genesee and Wyoming option. They had Genesee and Wyoming had provided us with some general layouts that I believe you had access to that showed multiple sidings coming along the road that you would build into the transload facility. Did you consider those? It looks like your design is different than what they had proposed. Can you talk to that?
As for the Baldwin site, we didn't design any additional rail at the Baldwin site. All we did was look at the operational analysis and then design a truck circulation.
And you had adequate storage without additional siding, or you didn't consider that?
We considered the storage tracks that were located a half-mile away to the west, and then using all the sidings. I think they had 3 sidings at the Baldwin track.
Okay, thank you.
Well, I'm gonna ask a couple more quick questions, nobody else does. For the Cadillac, I didn't pay attention to this earlier, but the trucks are moving clockwise, which means that they're gonna be crossing each other's paths. Did you ever thought about making them go the other way around so they wouldn't have to cross each other?
It'd be too sharp of a radius when they turn right there, right after that first grade crossing. Be too sharp of a radius to get stored.
But they're gonna be turning then left when they come out of there anyways.
Well, that's longer. It's a longer distance.
Oh, I get that.
Yeah, you need, because of how tight the building is.
Yeah.
Yeah.
Okay, interesting.
That brings up another issue. Did you look at left-hand loaded moves as compared to right-hand loaded moves? When you make a left-hand loaded move, you have an inherent problem because the truck's fully loaded and it has to cross traffic, where if you make a right-hand loaded move, you don't cross traffic.
With your truck analysis, did you pay attention how many left turns you had in your selected routes when they were going low?
No, we did not take that into account. We just took into account like a couple of intersections that we saw that were issues, but we didn't actually differ if they were unloaded or loaded.
Just as an example, UPS says they have a 20% fuel efficiency increase by making right turns only. So they don't have to cross traffic, they don't have to wait as long for their turn movements.
My final question is just asking for a little bit clarification. So you talked about the Genesee, Wyoming versus the Great Lakes Central, but And you kind of highlighting, why is it important? Why does it matter what the railroad is or?
For competition, if you're tied to one railroad and they want to increase the price, you don't have a choice, you have to deal with it. But by having access to two different railroads, you could have them bid against each other for especially with how large of quantities we're moving, they would be probably very willing to try and keep your business.
Right, but their access may be different for different locations. But if there's no further questions, thank you very much. Let's see. Well, I don't think we're gonna be getting an early lunch today. Looks like these guys are on a talking mood.
You can go to the updates and stuff, so.
Yeah, you guys.